Hello students, welcome to the topic differentiability. In my last video I discussed how to find derivative of the function using logarithmic properties and also when we have to use the logarithmic properties. In this video I am going to solve more number of examples on derivatives of the functions using logarithmic properties, and also if the logarithmic base is other than e, how to find derivative of the function, and also if the function is addition form, then how to find dy by dx. Let's see the first question. If y is equal to log x raised to cos x, then find dy by dx. Students, here you see the given example is function raised to function and it is a single function. There is no addition, subtraction or any product term. Okay, so in this case we take logarithm directly to the function. So first you write a given function, take log on both sides. So left side it become log y is equal to log of log x to the power cos x. Now log y left side as it is using log m raised to n property. So it is written as n log m, that is this power is multiplied. So therefore here cos x is the power term. So this is first written. So log y is equal to cos x log of log x. I differentiate this equation with respect to x. Log y derivative, you know that it is 1 by y dy by dx is equal to, now we have cos x into log of log x. It is a product term, product of two function. So therefore to differentiate, use product rule. This is the product rule formula. So using product rule, I write the derivative. First function as it is cos x. So derivative of log x. This is composite function of logarithm. So you know the formula, log of f of x, how it is followed, 1 upon f of x, then after that f of x derivative, that is a variable derivative. First we have to derivative log function, that is 1 upon. So here also you write 1 upon function is f of x here. After that function derivative is 1 upon x, that is log x derivative, plus log of log x as it is, cos x function derivative is minus sin x. So this is the way of writing derivative for the product as well as a composite of a logarithmic function. So next step, dy by dx is equal to, transfer this y right side, it become y into bracket. So writing the same function, cos x divided by x into log x minus, because here minus is there, so this minus into plus become minus sin x log of log x. So this is the solution. So in this solution here, y you can substitute from the given log x raised to cos x, otherwise you can keep y this as it is. This is not compulsion. Okay, so this is the way of finding derivative using log property. So now next go for another example. If y is equal to log x to the power x plus x raised to log x, then find dy by dx. In this example, we have addition of two functions. So in this case, we cannot take log directly to the entire function. Remember, whenever the given example, sum or difference of two functions, we cannot use log on both sides directly. Given y is equal to log x raised to x x raised to log x. So remember this point. If the function is sum of two functions, then we should not take log on both sides. Then what is the technique? The technique is very simple to find the dy by dx. In this case, the first function you consider as a u term or u function. Let u is equal to log x raised to x. So denote the first function as u, and another function, second one, you denote as a v, x raised to log x. So this is the technique. Take this as equation 1. Then y become u plus v. So differentiate this y function with respect to x variable. Here u and v are nothing but functions of x. These are also functions now. So therefore differentiation become dy by dx is equal to du by dx plus dv by dx. Now from equation 1 we have functions u and v. You find out du by dx and dv by dx, then substitute in this equation, that become dy by dx answer. So therefore you take this as equation 2. Now you find out what is du by dx and dv by dx. For that you take logarithm on both sides. Students, here u is function raised to function form, v also function raised to function form. Therefore to find the du by dx and dv by dx, I am using a log on both sides. Sometimes the v function may be, or any one function may be standard function. One function is a function raised to function, another function may be standard function, may be composite, or any function, simple function. In that case, the function which having a function raised to function form, only for that we take the log. Now taking log on both sides, both the equations, that is a u and v functions, we get log u is equal to log x to the power x, and log v is equal to log of x raised to log x. So using the property, so this x is multiplied to the function, that is x into log of log x. So here log x is the power, therefore log x function into log x it is, that is this log into this x, log x it is. So in the next step, so this log x and log x, it is the same term, so this become log x whole square. Okay, here this is a simple function, composite as well as simple function combination. Therefore I differentiate directly equation with respect to x and denote this log v function 3, equation 3. So first let me find derivative of log u. From this you find out, you will get a du by dx. So 1 upon u du by dx is equal to, again using the product rule, x as it is, log of log x function derivative 1 upon log x into 1 by x, plus log of log x as it is, x derivative is 1. So here x and x get cancelled. This x divided by x get cancelled. So and transfer u right side, it become du by dx is equal to u into bracket 1 upon log x plus log of log x. So next step, substitute u from the consideration. So it is a log x raised to x into bracket 1 upon log x plus log of log x. So this is compulsory, u function substitution. So this is a equation 4. Now this is du by dx function answer. Next is find dy by dx function answer, differentiating that equation 3, that is log v. So now from equation 3, log v is equal to log x whole square. So this function I am going to differentiate directly. So using a function raised to n form, log v derivative is 1 by v dv by dx. Log x whole square function derivative is followed in this way. Okay, it is function raised to n. Otherwise, remember this is a x square form. So this function is x square form. What is x square derivative? 2x. No, I follow the same thing. 2 into function log x, and after that a log x derivative, that is 1 by x, composite form. In place of x we have log x. After that derivative of this. I hope you understood how the derivative is written. Following composite of x square. X square derivative is 2x. Like that we write 2 function and after that function derivative. So dv by dx is equal to, transfer right side, it become v into 2 log x divided by x. So next is a substitution of v. It is x raised to log x and 2 log x divided by x as it is. So this is equation 5. Now this equation 4 and 5 you substitute in equation 2, that is dy by dx is equal to du by dx plus dv by dx. So that become the solution. So therefore now from equation 2 we have dy by dx equal to du by dx plus dv by dx. So therefore dy by dx is equal to du by dx and dv by dx is substituted from the equation 4 and 5. Here this is the answer. This answer you have to replace here in the equation 2. So first answer is log x raised to x 1 upon log x plus log of log x plus next dv by dx substitution x raised to log x 2 log x divided by x. So this is the solution. This answer is the, or this function is called derivative of the given function, and this is the technique. If we have a addition or sum or subtraction of two function, and in that if we have a function raised to function, this is the way of finding dy by dx. I hope you understood, students. Next example, if y is equal to a raised to x, where a is greater than 1 is a constant, then find dy by dx. Students, this is a exponential function where a is a now general term. It is not particular number, it is general. First I find the derivative of this a raised to x, taking a as a general. Then when you have a particular number, you have to follow that general answer. Okay, so first you write y is equal to a raised to x given function, taking log on both sides. So it become log y is equal to log of a raised to x. Log y is equal to, so using property of logarithm, it become x into log a. So in this right side now, x into log a, this is constant term. So x is multiplied to constant term. So therefore easily we can find the derivative right side. No need of using any rule. So log y derivative is 1 by y dy by dx, and x derivative is 1 log a as it is, constant it is. So dy by dx equal to y into log a, transferring right side. So dy by dx is equal to, or y substitution means function a raised to x function. So this is equal to, substitute y means a raised to x. From the given, substitute y a raised to x. Then what is a log a? So this is the right side is the derivative answer for this a raised to x function. D by dx of a raised to x is given by a raised to x into log a. So here just I analyze the solution, how it is written. It is very simple. Derivative of a raised to function always written as same function a raised to x and then multiplied log a, that means log of the base term. Okay, and logarithm base is e only, remember. So this is the way of writing derivative of a raised to x function. And remember students, this is a standard function. So take the example on that. If y is equal to 2 raised to x, then find dy by dx. Now this is the example or function on the a raised to x form. So given is y is equal to 2 raised to x, differentiate. Here I am not using log property to this function. Detailed solution I am not going to write. Direct derivative answer I am following. So this function derivative is given by dy by dx is equal to, so as I said in previous general form, same function into log of the base. So 2 raised to x function derivative is written as 2 raised to x. So this is the formula, 2 raised to x into log of base, that is log 2. So this is the way of writing derivative answer. Same term, same function into log of the base, always written in the same way. Okay, if you use the log property, then if you differentiate, the same answer will get. You are writing direct now. Okay. Suppose next the point is, instead of this x, if you have any composite, then how it is followed? It is in the same way, the same technique which we followed in the previous functions. Whatever the derivative rule is there, we follow that one, and then into d by dx of composite variable. Understood? Now I give the formula for that. If it is composite form, remember, if y is equal to a raised to f of x, that is composite variable. Now in place of x you will get some function. So then dy by dx equal to, it is followed in the same way. Same function, whatever the function is given with composite variable, same, and log a. After that d by dx of function. Okay. Same function into log of the base. After that composite variable derivative. This is the way of following. Okay. So for an example I take, if y is equal to 3 raised to sine x. Now you can see that here it is composite. In place of x we have a sin x function. So then dy by dx is given by same function log 3, and after that d by dx of sin x. So in the next step you write a derivative of sin x function, that become solution. Otherwise you can write directly here also, because it is a composite variable function, is a very simple function. Sin x, what is its derivative? You can write here direct answer, cos x. Okay, so otherwise, next step, 3 raised to sin x into log 3. So d by dx of sin x is cos x. So this is the way of following if we have a composite. Same function into log a or log of the base, and then derivative of the composite variable. I hope you understood, friends. So next example, if y is equal to x raised to x plus 2 raised to sin x, then find dy by dx. So here we have sum of two function. In that, one function is function raised to function, another is a raised to f of x, composite function. So here for one term you can use logarithm. For this also you can take log on both sides, nothing wrong in that, but it is a standard, no? So we can write derivative directly without taking log property. So first write y is equal to x raised to x plus 2 raised to sin x, given function. Then first you denote the first function as x raised to x u, and v as a 2 raised to sin x. As I said in the previous example, whenever you have an addition of two function, so this is the technique. Directly you should not take log on both sides. First function u and second one is v. Denote the functions u and v. Then y function become u plus v. Differentiate this equation, you will get to dy by dx is equal to du by dx plus dv by dx. Now from equation 1, you find out du by dx and dv by dx functions. So now here I am going to take log only for u function, because u is function raised to function form, v is standard function composite, a raised to f of x form. Therefore, I am not going to take log for this v term, only for u. Therefore, taking log on both sides only for u function, log u is equal to log of x raised to x. And here if I use the property of logarithm, it becomes x into log of x. Differentiate this equation, 1 by u du by dx is equal to, using the product rule it is written because it is a product of two function, x into log x. So therefore x as it is, log x, it is a standard, 1 by x, plus log x as it is, x derivative is 1, and here x and x get cancelled. Okay, so du by dx you will get u into bracket 1 plus log x, and du by dx is nothing but u substitution from the consideration, so it become x raised to x into bracket 1 plus log x. So this is equation 3. So this is du by dx function answer. Similarly, you find out dv by dx function. Now from equation 1, v is nothing but 2 raised to sine x. I differentiate this equation directly using a raised to f of x. dv by dx equal to same function into log 2 into d by dx of sine x. So in the next step, write the derivative of sine x. So that is 2 raised to sine x into log 2. Sine x derivative is cos x. So this is a dv by dx function. You take this as equation 4. Now from equation 2, dy by dx is equal to du by dx plus dv by dx. Now substitute du by dx and dv by dx from equation 3 and 4. The answers you replace it. That become dy by dx answer. X raised to x into 1 plus log x plus, and dv by dx function answer is 2 raised to sine x log 2 cos x. Further simplification not required. So this replace, when you replace it, that is a answer. I hope you understood, students. Okay, let me take another example. Okay, if y is equal to log x to the base 3, then find dy by dx. Students, here it is a different example. Now we have one function log x, but the log x function base is 3 here. We know the log x function derivative with respect to log base e, it is 1 by x. Now if it is log 3 other than e base, then how to find a derivative of the function is, we should not differentiate directly log x function. We have to use the log property. We have to change first this log 3 base, remember students. So therefore first you write given function and use, first you remember this point, if base of the logarithm is different, then use change of base formula taking new base as e, and this is the change of base formula. Log m to the base n, it is written as, here we have two formulas, students, you follow any one, but here I will write the answer using both formulas. The first formula is log m to the base n is given by log m divided by log n, and new base is taken here e only, e it is, nothing is written means e. Is it clear? Okay, another is to the same formula, if I use this reciprocal formula, 1 upon log n to the base m it is equal to log m to the base n. That means if you write the numerator, these two numbers are interchanged. Here we have the same case. 1, actually this divided by log n means 1 upon log n to the base e. 1 upon log n to the base e. If I write the numerator, it become numbers are interchanged. Therefore, what it become? Log m to the base e into log e to the base n. Is it clear? So this product is also nothing but change of base formula, and in this way also you can write this log m to the base n. It is very simple. Log m to the base, new base you write. After that, log new base to the old base. This is the way of following. Log m to the new base into log new base to the old base. Here base is e. Log m to the base e into log e to the base n. I hope you understood, students. So in both the way, you can use this property to the given example. So now first I use first one, log m upon log n, that is a log of this x divided by log of the base, that is 3. Now I differentiate this function. So left side it is dy by dx, and in this function, students, it is 1 upon log 3 constant. Remember, it is free from x variable, therefore it is a constant. Take it outside or write it first, and log x derivative write it, that is the answer, 1 upon x. So this is the dy by dx function answer. Now I use a second formula, this formula, and then I find the derivative. Here, given y is equal to log x to the base 3, and this is now written as, listen here, it is followed like this. First log x, and then here what is the base? 3. Now change it to e. When you change log e to the base 3, old base you take it. Otherwise you remember log x to the base e. After that log e to the base 3. This function you replace it by e always. This place term you replace it by e and write base same 3. Multiply. So this is the way of following. And remember, when you follow this one, this is constant. Log e to the base 3 is a constant. So only log x function you have to differentiate. Therefore log x, differentiate this with respect to x, dy by dx you will get log x derivative is 1 by x and log e to the base 3. Okay, now remember, students, whenever I give you now direct way of writing a answer or derivative for this type of example, whenever you have log of the function or log x base is different, you remember it is very easy to write the derivative answer. You first you don't worry about this base, you first log of the function or log x derivative you follow. Log x function derivative is 1 by x. After that you multiply log e to the base 3. That means this x you replace it by e. You just multiplication you take, that become a derivative answer. Once again I repeat, log x derivative is 1 by x, and then into, you replace this place term x, replace it by e, log e to the base 3. Okay, for example, if you have a log x to the base 7, log x to the base 7, then no need of using a change of base formula and then differentiation. Direct derivative. Log x derivative is 1 by x into log e to the base 7. Suppose if it is composite, if this is f of x, we follow the same log f of x formula we have to follow. Log f of x means 1 upon f of x d by dx of f of x. After that, that f of x you replace it by e, log e to the base 3, like that. Okay, I give you formula now, general formula. Remember, if y is equal to log x to the base e, then dy by dx is given by 1 by x log e to the base e. Okay, I explained this term, this product answer. log e to the base a. It is very simple. In this example only, e you make it, or e you take it. That is the solution. Or log x derivative is 1 by x. It is 1 upon log a. So using that another property, reciprocal, log e to the base a. If you write 1 upon, interchange the number log a to the base e. Here not required to write the base e. It is understood. Okay, now if it is a composite, log of f of x, then 1 upon f of x, derivative of f of x, then after that multiply log e to the base a. Or 1 upon f of x d by dx of f of x divided into 1 upon log a. So this is the way of writing derivative answer. This 1 upon log a is nothing but this logarithm term only, using property it is written. Either in this way you can write the answer, or multiplying log e to the base a you can write the derivative answer. It is left to you. So any one answer is followed. Okay, I will take the example on that. If y is equal to log 5x to the base 4, then find dy by dx. Okay, now this is a log f of x and base is not e, 4 it is. Okay, so I write derivative directly here. First you write given function. I am not using change of base formula. Directly I am writing differentiation. Dy by dx is equal to, now follow the log f of x, as the base is e, no, we follow in the same way you differentiate log f of x, 1 upon 5x into d by dx of 5x, that is a logarithmic composite. After that what we have to multiply to the answer, log e to the base 4. Okay, otherwise you have to take 1 upon log 4, that also you can multiply. So next step, 5x derivative is 5 into 1 and log e to the base 4 as it is. Remember this term why we write means, when we use a change of base formula, this term we get there as a constant, we keep this as it is and then we differentiate, no. So therefore here we are keeping we are multiplying this term directly. So don't be confused, sir, how this log e to the base 4 comes. Okay, when we use change of base formula, this term we get in that function and we keep that one as it is, remaining function we differentiate. So here what we are doing, we are writing directly function derivative, then we are using this we are multiplying this extra log e to the base 4. Okay, so here 5 and 5 get cancelled, so we will get log e to the 1 upon x log e to the base 4. So this function is the derivative answer. I hope you understood, students. So take one more example on based on that. If y is equal to log of log x to the base 7, then find dy by dx. Now what is the base of logarithm? 7. First you write given y is equal to log of log x to the base 7. Differentiate with respect to x. First you differentiate log of log x. Okay, you consider this as a e now. Differentiate the function with base e. How we differentiate? In the same way. Log of log x means 1 upon log x into d by dx of log x. After that you multiply to this answer log e to the base 7. Okay, that means change of base formula is not required to apply. Directly you can write the derivative. So dy by dx is equal to 1 upon log x as it is, derivative of log x is 1 by x, and log e to the base 7 as it is. So this is the derivative answer. Let me take one more example. Log of, if y is equal to log of sin x to the base x, then find dy by dx. Now dear students, now base is not number, it is also a function x. In this case compulsory we have to use change of base formula. If number is there, you can write directly answer. If number is not there, if any function is there in the base, we should not follow that rule. That is direct method of writing differentiating. Given y is equal to log sin x to the base x. So now I use the change of base formula, the first one, log of sin x divided by log of x. This is the way of writing change of base formula. It is very simple. Log for this sin x and log for this x. That is log for the base, log x. I differentiate this equation now. dy by dx is equal to, so this function is now division form or rational function. So you know the rule, quotient rule, it is called f upon g. G as it is derivative of f minus f as it is derivative of g, then whole divided by g square. So I follow the same rule, log x derivative of log sin x minus log sin x as it is derivative of log x whole divided by log x whole square. So log x as it is, now you write derivative of log sin x. It is 1 upon sin x into sin x derivative cos x. Direct I am writing. Log f of x, 1 upon f of x or 1 upon variable. After that variable derivative cos x. Minus log sin x as it is, log x function derivative is 1 by x. Whole divided by square of the logarithm. That is log x whole square. Dy by dx is equal to, now cos x divided by sin x means cot x. Remaining, write it as it is, log sin x divided by x whole divided by log x whole square. So this is the derivative of the given function. I hope you understood. If you have a base is number, how to write the derivative? Okay, directly we write. If base is not number, if it is any function, then change of base formula. First we have to apply, then we differentiate using the rule. I hope you understood, students. Thank you.